Okay, so let's see another question on the empirical formula and molecular formula. Okay, so let's get started. So we have the question as follows, that the hydrazine is a compound which contains 87.42% nitrogen, 12.58% hydrogen, and molar mass of the compound is 32 gram per mole. So you have to calculate empirical and molecular formula of hydrazine. Okay, so hydrazine contains 87.42% nitrogen and 12.58% hydrogen, and molar mass of hydrazine is 32 gram per mole. So what is its empirical formula and molecular formula? Okay, so obviously these are by mass. So let's say that we have 100 gram of hydrazine, in which 87.42 gram nitrogen is present and 12.58 gram hydrogen is present. Okay, so number of moles of nitrogen would be 87.42 over 14, which gives us 6.29 number of moles, and number of moles of hydrogen would be 12.58 over 1, which is 12.58 only. Okay, so the empirical formula would be so the relative ratio of N is to H moles would be 1:2. Hence we would have NH2 into N times, or NH2 N would be the empirical formula. We need to find the value of N. Okay, and for the information, we have been given the molecular mass of the hydrogen compound is 32. So here we can find that empirical formula is 16N. Okay, and so we can say that molecular mass, or rather molar mass, is molecular mass would be NH mass of NH2 times N. So NH2's mass is 16 times N, and we have given the molar mass as 32 rather. So N would be 2 here. Okay, hence molecular. So this is the empirical formula, which is NH2. Okay, so molecular formula would in turn be NH2 whole N, and here we actually needed to find out the value of N. So we found out the value of NH2, hence molecular formula would be N2H4 and empirical formula would be NH2. Okay, so next let's see another question wherein we have been given an organic compound which has molar mass of 164 gram per mole, organic compound. Okay, and it contains 73.2 percentage of carbon, 7.28% of hydrogen, and remaining is oxygen. Okay, so let's say total 100 gram of organic compound is there. Okay, in which 73.2 gram carbon is present, 7.28 gram hydrogen is present, and remaining is 19.52 gram oxygen is present. So number of moles of carbon would be 73.2 over 12, which gives us 6. Similarly, number of moles of hydrogen would be 7.28 over 1, which is 7.28 itself, and number of moles of oxygen would be 19.52 over 16, which is 1.22. Okay, so next ratio of moles of C is to H is to O would be, if you can just calculate it, it would come out to 5 is to 6 is to 1. You have to just apply basic algebra of multiply and divide over these terms, and the basic ratio will come out to be 5 is to 6 is to 1. So hence empirical formula is C5H6O, and molecular formula would be C5H6O whole times N. Okay, so we have been also given 164 gram per mole as the molar mass. Okay, so we have to just calculate the mass of this, multiply with N, and equal it to 164, we can get the value of N. So in this case will get after calculation, you can do it yourself, N comes out to be 2. So the molecular formula would be C10H12O2 would be the molecular formula. Okay, so let's see another example wherein we have 1.32 gram sample of, let's say, organic compound was burned to air to yield 2.904 gram of carbon dioxide and 1.584 grams of H2O. Okay, so if the original compound contained only CHNO, it's already given in the question that it's an organic compound which contains CHNO. What is the empirical formula of the organic compound? Okay, so we have 2.904 gram of CO2. Okay, so obviously C plus O2 gives CO2 because we are burning it in air, so carbon will interact with carbon in the organic compound will interact with oxygen to form CO2. Okay, so how many number of moles of CO2 were formed? So moles would be 2.904 over 44. Okay, so these were the number of moles. Okay, and if we have to calculate the weight of carbon, this carbon which was used, then we have to multiply it with the molar mass of carbon with the number of moles. Okay, number of moles of carbon in CO2 would be coming from the carbon atoms in the organic compound. Hence weight of carbon atom in the organic compound can be calculated, and this would be molar mass is 12 into 2.904 over 44 will give us 0.79 grams. Similarly, hydrogen atom from the organic compound will react with half mole of oxygen to form H2O. Okay, similarly we can calculate the weight of hydrogen would be 1 into how many grams of H2O was formed, 1.584 over what is the molecular mass of H2O, this would be 18. Okay, so this will come out to be 0.176 gram of hydrogen was consumed. Similarly, we can say that third, we can say that what is the mass of oxygen consumed. Okay, so mass of oxygen would be mass of organic compound minus mass of hydrogen minus mass of carbon. Okay, so this would come out to be 0.352 grams. Okay, next let us apply a ratio method. So we can calculate the number of moles of carbon present in the mixture via dividing the weight of carbon in the mixture over the molar mass of carbon, which is 12. So this will come out to be 0.066. Next, number of moles of oxygen present in the mixture would be 0.30 or rather 0.352, which we just calculated, over 16, which will come out to be 0.022, and number of moles of hydrogen would come out to be 0.1762 over the weight of the molar mass of H2 would come out to be 0.162 over 2 would come out to be 0.088. And why we are taking molar mass of hydrogen is 2, or why we are taking H2? Because we burnt H2 in air with oxygen atom. Here we used H2 from the organic compound. The weight of H2 was 0.176. Okay, so we use H2, not hydrogen atom, from the organic compound. Hence here also we will be using the number of moles of H2 in the organic compound. So number of moles of H2 in the organic compound is 0.088. Okay, now you can apply the simplest ratio. So simplest ratio would give carbon as 3, hydrogen as 4, and oxygen as 1. Hence empirical formula for the compound would be C3H4O. Okay, so this would be the answer. So with this we come to an end of this lecture. In the next lecture we would be discussing on some more concepts on stoichiometry. Okay, so till then, good luck and goodbye.